Do you want to make the most out of your GPU resources when running AI/ML workloads? GPU sharing is one way to increase your GPU utilization. Welcome to Container Bytes. I'm Mofi.
I'm Ali, and let's talk about it. There are a few different ways to share GPUs in GKE, starting with multi-instance GPUs. GKE divides a single GPU into up to 7 slices, and then each slice can be allocated to one container on a node independently for a maximum of 7 containers per GPU. Multi-instance GPU provides hardware isolation between the workloads and consistent and predictable quality of service for all containers that are running on the GPU.
The next form of GPU sharing is called MPS. GKE uses NVIDIA's multi-process service, or MPS for short. MPS is an alternative implementation of the CUDA API designed to enable cooperative multi-process CUDA workloads to run concurrently on a single GPU device. GPU with NVIDIA MPS provides software level isolation in terms of resource limits. The final GPU sharing mechanism on GKE is called GPU timeshare. GKE uses the built in time sharing ability provided by the NVIDIA GPU and the software stack. Starting with the Pascal architecture, NVIDIA GPUs support instruction level preemption. While context switching between processes running on a GPU, instruction level preemption ensures every process gets a fair time slice. GPU time sharing provides software level isolation between the workloads in terms of address space isolation, performance isolation, and error isolation. Let's take a look at the key differences between these three technologies and how to choose the right one for your workload.
In terms of partitions, multi-instance GPUs provides a physical, hardware-level partitioning of one GPU in up to 7 slices. Multi-process service, or MPS, allows for up to 48 parallelized partitions, which are logical partitions, whereas GPU time sharing allows for as many partitions as you want, where each partition allows one process to access the GPU in its entirety.
Because multi instance GPUs are hardware level partitioning, we can get performance and error isolation, memory limits, and memory bandwidth quality of service guarantees. MPS, being a logical partitioning, does provide performance isolation by percentage, but it does not provide error isolation. It does have memory limit per process, but cannot provide guarantees for memory bandwidth quality of service. GPU time sharing can have performance and error isolation, but because each process gets to see the entire memory bandwidth, it does not provide guarantees for memory limits or memory bandwidth quality of service.
In terms of observability, you can use cloud monitoring to monitor the performance of your workloads using multi-process service as well as GPU time sharing. GPU utilization metrics are not available for multi-instance GPU partitions. However, you can still monitor the GPUs as a whole in cloud monitoring. In terms of reconfiguration of partitions, multi-instance GPUs can only do this when idle, meaning this is a destructive operation on the node. Multi-process service can support reconfiguration of partition at process launch, whereas GPU time sharing is completely dynamic. So if we have a GPU node with GPU time sharing enabled with one workload running on it, that workload gets all of the GPU's resources. And as new processes come online looking for those resources, the GPU is shared between them.
Multi instance GPUs are best suited for workloads like inference and workloads that require quality of service guarantees. For example, when running AI inference workloads, multi instance GPU allows multiple inference queries to run simultaneously for quick responses without slowing each other down. MPS is best suited for batch processing. For example, MPI jobs with inter-MPI rank parallelism. With these jobs, each small CUDA process can run concurrently on the GPU to fully saturate the whole GPU. GPU time sharing is best suited for bursty or interactive workloads. For example, when multiple users test or prototype workloads without idling costly GPU.
Let's take a look at how we can create a few different GKE clusters with these three different GPU sharing strategies enabled. First, we're going to look at multi-instance GPU, which is the default GPU sharing strategy in GKE. The GPU partition size parameter can be used to specify the shape and number of partitions. In this case, we're specifying each of our partitions to have 5 gigabytes of memory. On an A100 with 40 gigabytes of memory, That gives us a maximum of 7 of these partitions. For MPS, we set the GPU sharing strategy to MPS and set the maximum number of shared clients per GPU, which in this case we set 3, but can be up to 48. For time sharing GPU, the GPU sharing strategy needs to be set to time sharing, and the maximum shared clients per GPU needs to be set.
In this video, we got a high-level overview of all the different GPU sharing techniques available on GKE. In the next videos, we will take a deeper look on how to enable each of those techniques and an example of how that works in practice.